Welcome to Tribecast. Today we are having Craig with us. He is head of engineer at Old Mutual Limited. And today's topic is solving the root of software problems. Okay. And before starting, a huge shout out to Browser Stack, our exclusive sponsor for all our community events and premier sponsor for conferences. Now about Craig, I'll just invite Craig on the stage. I'll just a second. I think Craig is here. Yeah, perfect. Hi, Craig.
Hi, Arun. How are you?
I'm great. I'm great. Thanks for asking. Craig, you can share your screen, give us a brief intro about yourself, and then we are good to go.
Great. Um, Everyone should be able to see my screen.
Yes, your screen is visible.
Perfect. Thanks. Yeah. So my name is Craig Risi. I will be talking and introducing myself during the presentation. But I first want to just welcome everyone just to this talk. And today we're going to be talking about solving the root of software problems. And the reason why I feel like this is such a good topic is because I have found in my experience that the majority of times when we're trying to fix issues within our software development space, we tend to focus too much on the symptoms rather than what's actually causing the root of our problem. And so today I want to speak about why we need to focus on that root and not so much just dealing with the symptoms, but then also some strategies as to how we can go about trying to identify what is the cause of problems within our organizations. Um, just a little bit about me. My name is Craig. I am a head of engineering at a company called Old Mutual. It's one of the largest financial companies within South Africa, and it's 178 years old. And our software engineering space is over 500, of which there's about 150 testers. And so it's something that I'm very passionate about. I've been involved in testing my entire career, and something which I'm really passionate about. I have a website and a blog where you can see over there. And then I also do board games. So if you're interested in board games and ever want to play some board games, there's risky games as well, which I also own. And I've got 12 games published there if anyone wants to go play board games. I've also got a book out called Quality by Design, which is really just about looking at software quality from the beginning. So not so much just looking at it from a testing perspective, but how do we look at software from a design perspective to make it of a better quality? So it looks at things from all the way at the conceptualization of an architectural design, all the way through to testing and automating at the end. And if you're wondering and trying to place my accent, I am from Cape Town, South Africa, a city and a country which I absolutely love. And these are just some pictures from my beautiful city. And I'm a really passionate South African fan, particularly when it comes to cricket and rugby and all sports. And so, yeah, really just passionate about that and really encourage you to visit if you've never been. But let's get back into the topic, the root of the problem, and really just trying to deal with the root of the problem. And like I said at the beginning, I feel like we spend too much time trying to deal with symptoms when we find a problem. Now, what's the difference between a symptom and a root? Well, a symptom is often how software or an issue manifests. So a software issue will manifest by we see an issue on the screen. We now need to go and whether it be an error label, a warning label, we now work towards trying to fix and rectify the warning label. And then we rectify the warning label, we rectify whatever that issue was. And now we go into production because we're like, well, that issue is no longer there. And then we move on. So we successfully found the bug, we fixed the bug, all's good. The problem with that is that it creates a thing where we just then start to focus on the symptom, because what you did there was you fixed the bug that you identified, but you didn't really identify why did it occur in the first place. What really happened? Why did we get this error message on our screen? Where did it surface? Why did it surface? And we're not asking the deep enough questions. We just know it surfaced. We might identify, oh, it was in this code that the issue was. So let me just fix that code. Maybe we'll fix the test, along the way because, we want to be able to fix the test. But that's not really a healthy way to be able to do it. And generally, I find that we tend to fix symptoms and not root causes. We focus too much on what we see, and we want to fix what we see rather than actually trying to understand the real problem at hand. And I think that is very vital and something which I really want to focus on. And the issue with this is what it does is it leads us firstly to waste a lot of effort. So we tend to waste effort as teams. Why? Because we end up constantly reintroducing the same defects. So we think, yes, I fixed this issue. It's done. I've now pushed it into production. The problem is you're going to get lots of those type of issues constantly resurfacing because you fixed the issue, but you didn't fix why the issue occurred, which means the likelihood of that issue occurring again somewhere else in some other piece of code is quite high. And so we end up wasting effort because we're fixing testing, fixing testing, fixing testing, as opposed to stop, let's find the real problem and fix it so that it doesn't occur again. Yeah, we're wasting effort. We end up repeating our mistakes, which I think can be very frustrating for teams and particularly testers because they're going in here, they're logging bugs, they're going through sprint cycles, but it's very frustrating when you're trying to work and produce good quality software and sprint in, sprint out, you're finding the same types of issues along the way, and you can sometimes think, what is the team doing? Why they're writing this code? What's happening? Why do we keep making the same mistakes time and time again? And that's often because we're focusing too much on the symptoms and trying to address the symptoms and actually try and find the real reason as to why the symptom occurred in the first place. It increases our testing effort as a result. It creates a lot of technical debt because we end up just creating a stack of things that aren't getting addressed because we're not really fixing that root cause of an issue. We're just fixing the surface things of what we see. We're fixing that visual bug that we can see. We're fixing sometimes that performance bug that we can see, and we say, okay, well, that's a bit of a slowdown. We fix the slowdown, but we don't fully understand maybe how that occurred somewhere else in the system. And so you just fix it at a surface level, and now it's going to surface somewhere else within the system, either in your application or in another dependency downstream or upstream, but you're not fixing the problem in entirety. And that just creates a lot of technical debt that needs to be addressed at some point in time because you haven't solved the problem. You're just constantly fixing, and then there's a list of things that actually need to be done to improve your software is not getting dealt with. And all of this leads to excess maintenance and slower delivery. We live in an age where we want to deliver code software. We want to get from from specification to deployment as fast as possible. We want to deploy multiple times a week, sometimes multiple times a day. We want to be agile. We want to be fast. You can't do that if you're constantly having this result of bug fixing, bug fixing, bug fixing. It slows you down. You end up wasting too much time fixing minor bugs, minor issues all the time, sprint in, sprint out, and then you lose trust in the whole process. And it just leads to excess maintenance, slower delivery, everyone gets frustrated. So it's not a healthy thing to do. We want to move away from a culture that focuses on fixing symptoms and rather work on the root. Another big thing is that it creates a bug fixing culture. I think this is a particular one, and this is why I gave it a point on its own that I think is quite pertinent, is I've seen a lot of organizations almost pride themselves at the number of bugs they find. I've spoken to a lot of testers who pride themselves at how great they are at finding bugs, and they see their value in being able to find bugs within the software process. So they feel like we've had a sprint, we found a lot of bugs. Next sprint, we found a lot of bugs. Next sprint, we found a lot of bugs. That's like I'm doing my job as a tester because we're finding bugs and we're fixing bugs and we're making things better. The problem is that that's actually not what a tester should be doing. And this might be, a bit of a mind-breaking thing for you, but as a tester, and I'm not going to go to, as a tester, you need to be focusing on not fixing bugs, but preventing bugs from happening, getting to the root of the problem. What that means is that, and this is how I said, you can't say that you've completely fixed the problem and that you've satisfied until you've really understood why it occurred in the first place. And to put it to that whole bug fixing culture thing, we shouldn't be focusing on fixing bugs all the time. We should be happier when we're reducing the number of bugs we're getting every single sprint. In my career, I've worked on some projects where we've had a lot of issues, and then we try and minimize it. And I once worked on a project where we started out with a lot of bugs, but we even got to a point where we had sprints where I couldn't find any bugs. We did all of our testing, both exploratory, ran all the automated tests, and we couldn't find anything. Does that devalue me as a tester? No, to me that's us making progress. We are no longer finding bugs, that means we've done something right because we've worked hard to prevent the issues from occurring in the first place. And that's what it means to get to the root of the problem. It's about trying to identify the real cause of issues to prevent them from occurring. We all have bug life cycles. I'm going to show this diagram. This is a very high level one. Hopefully you've got one that's a little bit more complicated than this. But typically we all have a bug life cycle where we log a bug, we assign it to someone to get fixed. They either reject it, defer it, duplicate it, or they actually fix it. It then gets retested by us, and then we say, okay, we're happy with it. If we're not happy with it, we might reopen it, but otherwise we say it's verified and closed, and that's the end of the bug life cycle. The problem is that that's an incomplete bug life cycle, because what you really want to do is, before you actually close anything, if you don't know what caused the issue, can it really be closed? I think we're too quickly trying to move from finding an issue to saying, oh, it's verified, now I can close it. What does closed really mean? And to me, closed means that we fully understand what happened. We fully understand what occurred, so that we believe that it's not going to happen again. And I think that's the other thing that I want to try and say is, if you can't guarantee how to prevent the issue from reappearing, then have you really fixed it? So again, another one of those things that gets us thinking. We can't close it until we fully understand what happened and how this issue occurred. But if we can't guarantee that we can prevent an issue like that from reappearing within the system, then have we really fixed it? Have we really identified it? And that's what this talks about, like really delving into the real problems that are facing our teams. And I've experienced this many times within my career where, again, we're fixing surface level defects. We find an issue, we see the symptom of it, and we start to fix the symptoms. But there might be an underlying thing. Now, that underlying thing might not be the piece of code where the issue is. Maybe there was something deeper down going on where maybe, and this has happened a lot, where the requirements weren't right. So not just for this particular issue, but overall, we're picking up a lot of issues within our requirements. And maybe the issue sits with the requirements aren't getting defined right, rather than the code being an issue. Or maybe the code was exactly as the developer was supposed to put it, but maybe there was a up downstream dependency where we didn't get the right information about, and now that's the reason why it's broken. So what's the root cause of the issue? Well, it's certainly not just fixing the code. So if we're finding that bug and then we see the code that's causing it and we fix that piece of the code, we can't now say that we satisfactorily fixed it, because why did we miss it in the first place? Why couldn't we catch it earlier? That's because there was a part of our system we didn't understand. Why didn't we understand that part of the system? Is it a process issue? Is it an information issue? Are we not asking the right questions? How do we get that right? Do we update the documentation to be able to better assess it? Is there a process thing that we need to implement within our organization so that all information from our up and downstream dependencies get to us better? These are the questions we've got to start asking. It's about how do we prevent this issue from occurring again? And I think that needs to be the mind shift that we as software testers need to make within our organization. Our job is to reduce the number of defects. Our job is to find the root cause of the problem. It's not to find bugs. It's not just to run test cases and automate test cases. It's to make our software better. And the only way to make software better is by delving really deep into the understanding of what is going, both in what's going on with our software from an architectural perspective, because often it's architectural designs, and architecturally the software is flawed. And then we going to constantly have issues of that nature because there's a fault in the design of the software that we've got to fix the design. Often it could be a process issue where we're just doing something wrong as a team from a process perspective that's allowing errors to creep in. It could be a requirements issue. There's a variety of things, and we'll go into that. But really what you need to do is try and uncover these things as much as possible. But it's looking at how the defect occurred to the what can be done to prevent it from happening again. So no longer just about what the fix is and what needs to be done to get things live. And I understand sometimes we do have things and we've got to keep our software operational, and we find issues and we've got to fix them very quickly so we can get the bug through to production. But then again, we shouldn't close it. We don't say, okay, we've now put it into production, we've deployed it, let's close it now. No, we don't close it until we're completely satisfied that we know how to prevent it from happening again. So we've moved from finding an issue to not just to understanding the symptom, fixing the symptom, understanding what caused the issue, but now what actually needs to be done to prevent it from happening. So again, we're going layer after layer there to make it really deep, and we shouldn't be satisfied until we know what to do to prevent it from happening again. Another thing which I think is important is, and I thought I'd just make a mention of this, is it also brings a lot of collaboration within the teams. I find when we fix symptoms a lot, what tends to happen is we're finding bugs. The like developer is fixing the bugs. We're finding bugs. It can often create an us versus them mentality. When we work on fixing issues together and fixing the real root cause of an issue, it requires collaboration, because there's often things that you can't do as a tester alone, and there's often things that the developer or the architect might not understand well enough from what your test is doing, and it requires everyone to work together. And so if you really want to start changing your culture and bring a culture where you are working more collaboratively, this is what will help. And if you really want to gain the respect of your development team, help them get better so that they don't have to spend their time fixing defects. I've been a developer as well in my career, and fixing defects can be annoying. Why? Because you like doing the fun stuff. You want to work on a new feature. You want to build that new thing. Having to go back and constantly fix things over and over again, it's tiring. It's not the fun part of the job. It's tough trying to solve those problems. That's the part that frustrates people. And so if you as a tester are focused purely on just logging bugs the whole time, people, they're going to get frustrated because they feel like it's constantly slowing me down. Yes, it might be something, a mistake they made, but often it's not a developer mistake. Often, like I've said, the developer's doing exactly what was expected of them, but there's still an issue as a result of what's happened, and now they've got to go and unpack and figure out how to fix this. But rather you as a tester saying, I want to help us solve this problem so we don't have to do it again, and we work together, and we stop and rather understand the issue better from a process perspective, from an architecture perspective, from a design perspective. That helps you to obviously get to less defects, but it also helps your developers to be on your side, because they're like, I want to work with this tester because this tester makes my job easier long term. We're not just constantly fixing bugs. They really care about making this better, making my job as a developer easier. And I think that's an important thing to understand, that if you really want to break the divide between developer and tester, we've actually got to learn to work together. And to do that, that starts by really getting to the root of issues. And if your developers can see you passionate about trying to solve problems and really unpacking not just that the defect's fixed, but actually unpacking why, wanting to go deeper into the code and say, well, let's go into the code together. Let's unpack the design. Why did that happen? It'll help to be able to get there. But I also understand that, well, these are typically the types of questions that we'd want to ask. So it's, what does the defect issue look like in production? I think that's the obvious one from the symptoms. What is causing it to occur? That's the obvious one. Where is it occurring? How do we fix it? And then how do we ensure it doesn't happen again? Again, this is the process of questions to ask if you want to go through it again within that. There's also some technical questions that we now need to start delving into. It's the do we have clear requirements? So we understand what needs to be done to fix it, but let's ask ourselves, did we actually have clear requirements when we started this whole thing? Were we actually happy with this? Maybe there was an assumption made by the architect or the engineering lead or the developer about the way they were building it because of something said in the requirements. Let's ask ourselves and be critical. Were we actually happy with the requirements that we got? And it's important to ask that. Did we make any technical assumptions? So again, we're not just going from these questions, which I think are quite common. We're going into asking deeper questions. But what technical assumptions did we make? Was it something around our dependencies? Maybe how we thought this other team's API would work, how we thought this integration would work, how we assumed the data would look based on what it told us, or did we really know how things were made? Was there anything made from a technical assumption in terms of how this was going to be running? We ran it in a container that was maybe the wrong size, and then you deploy it into production, and there's performance constraints because you've wrong sized your container and you didn't quite understand the load that was going to be put on it properly. There's a number of things that we can put in here, but it's important that we ask ourselves the question is, was there anything that we assumed? What was not clearly specified? And what did we make an assumption on as a result of that? what data constraints are causing the issue? Because again, a lot of times it's not just code that's causing issues. There's a lot of data issues, and generally I find data causes more issues, particularly within the financial space that I'm in. Often data causes more issues than anything else. We've got the code. The code's working exactly as expected, but there's so much detail in the data, and there's so much constraints and difficulties in terms of trying to understand our customer data that it's very easy to miss things from a data perspective. And what customers are doing unusual things with the data, and things that we haven't thought of. What are those constraints? Do we understand the data? What about the data is causing all those issues? Do we understand it? How does that particular issue, or this particular issue we're fixing, how does it impact our security and performance? So it's not just about us logging a security performance issue, but now that we're making a fix of it, how does this fix address the performance and security of the software? Have we thought about that? Have we put those measures in place? Do we fully understand how this change will impact other parts of the application? What are some of the pieces of code used in the software? And I think this is another key thing. We fix an issue once and we move on, but we live in a very we live in a very modular IT space where code is shared all the time and libraries are constantly reused. If we're finding an issue somewhere in the code, what else is calling on this code? Who else has copied and pasted this code somewhere else? Because let's be honest, we're copying and pasting code all the time. So if an issue appears in one piece of code, there's a good chance that a similar issue is appearing somewhere else in the code, because maybe someone has copied your code and the logic you followed and put it somewhere else in something that they thought operated similarly. Are we aware of that? Where else is this code being used? How do we get there so we don't just fix this defect, but we fix that defect everywhere where it occurs? Plus, also, we revisit the whole reason of why we landed up with this pattern in the first place. What is wrong? And then the last question that we need to ask critically is, how can this code be tested better? Because we obviously missed something. Something got into production, there was an issue, even if something was just picked up in the testing space, how do we pick it up sooner? I'm a huge advocate for shifting left on the testing space. And even if we're catching everything at a testing phase, I'm always asking the question, well, how do we catch it sooner? What could have changed so that the developer could have unit tested that better? Did the developer unit test that better? How can I help the developer to unit test better? What needs to change from a software design perspective to make the software more testable so that it's easier to write unit tests? There's a lot of questions that we can ask to unpack deeper and help us understand what's going on with our software. And these are the critical technical questions that I feel like we're often not asking. We're all good at asking these questions and going through that. We might not ask that last one in terms of how do we ensure it doesn't happen again, but I don't feel like we ask enough of the technical questions that really delve into the root of what's going on with our applications. And these are the things that we should always be looking into when we find issues, particularly in production, but also in our test environments, really making sure that we understand what's going on. But now I understand that this is not always easy, and this takes a lot of time. And I will say this up front: to stop and take time to figure all this information out for a defect is going to take a lot of time. Sometimes it can be solved in a couple of hours. I've experienced some issues where it takes a couple of days to figure out what really happened. Either where in the code or where the misalignment was made, going all the way back to the requirements, trying to figure out how we conceptually put all this together. To fully answer all these questions can sometimes take a long time. And like I say, sometimes it can take days. If we now want to be constantly focusing on delivery, where do we find the time? And I think that's the biggest issue, is trying to find the time. And we also think about just scale. I mean, it's fine if you're a small team and maybe you've got just a couple of small releases here and there, and you've only got a few defects that are coming through every single sprint. But what if you're on a team that found 100 defects? What if you're in an organization like mine where we have well over 100 teams, and within those 100 teams, they're constantly logging defects both in production and during the testing phase all the time. They can't all individually go ahead, and each team now has to slow down and focus on fixing every single defect. If you think about that, 100 teams, even if they're logging five defects a sprint, and now they've got to spend all that time coming together, we're just never going to deploy. Let's be honest. We just don't have the time. And that's why I think trend analysis is so important. And I think, if you really want to get there, it's trend analysis is that step that's going to help you to identify how to solve the root cause of the issues within your organization. And this is a quote from Albert Einstein, which I find very, quite relevant. It says, if you want to know the future, you've got to look at the past. And so if we want to be able to better identify how to fix issues within our future, we've actually got to start with that past. And I think this is something that, again, we don't need to worry too much about always fixing the issue now, because how long have we been using our bug tracking systems? How long have we been testing for? We've already got the information. And often by the information we've already got within our defect tracking tools, we might already have enough information to solve some of the problems we're currently having. And this is where trend analysis comes in. So what does that look like? So from a trend analysis perspective, what I'm saying is, you're going to go to your test management tool. And now, hopefully some teams have got into the habit of categorizing their defects in a bit more of a clear way, but often they don't. So you might need to go back and just start doing some high level categorization and going back in your test management tools and say, okay, well, we've got this tool here. This was what we did to fix it. Can you remember what it was? If we can't, we'll leave it. But if you can, maybe you categorize and say, we had a code issue, here's a requirements issue. I remember this was a design issue. You start to high levels, try and start piecing things together as best as what you can for everything in the past. You don't have to go back too far. Maybe you just pick the high priority ones, depending on how much numbers you're working with. But then everything from current, you're now going to start prioritizing. So we're saying, okay, we're going to look into the root cause of this. We don't have time to go into every single issue that we're facing. So what we want to do is at least just peg it towards something. Let's just give it a category and say, we weren't happy with the documents, and because of the documents, that's what led us to make this mistake in this code. Boom, there we go. There's a security issue. We had to fix the security issue. We're going to log it as a security issue. We're going to put these things in. That allows us to be able to start prioritizing and getting a trend on what the common issues are within our organization. I think this is why this is important. Is, again, we can't do this on everything. But like if I had gave you a pie chart like that, I could tell you straight away just by looking at this that, okay, 26.8% of our code is causing issues here. So I know that we need to address something within our code. Now, what is that? That could be improving unit test. Maybe there was an issue in the code, but maybe it's because we didn't unit test it properly. Maybe we're just not understanding things properly, and that's something that we need to look into. So how do we better understand that? But the point is, we know, okay, code is the common point of the issue. Let's address it. We also know that requirements are a big problem because we've identified that. So we know that we're having requirements difficulties within our space because we're getting too many issues that have been made because our requirements weren't clear. We know we have a requirements problem within our organization. Let's fix that. So what it does is we can't understand the root cause of every single issue as a result of that, but this does allow us to now start digging deeper, just to be able to see, okay, well, what do we do now to address the requirements issues within our organization if I can't fix everything? So this trend analysis becomes important. How do we do that, and how do we start that categorization process to help us get this information we need? I think it starts off by identifying the correct types of defect types. So when we log in a defect, it's what type of defect is it? Was it a feature defect? So feature defect, it's a new feature we're working on, and the feature failed. Feature defect. It's a regression defect. This was something which we picked up in regression. So it's something that we picked up in the past, we picked up in our regression. So it's not part of the new feature we developed, but we found an issue in regression. So regression defects. Performance defect, there's an issue with that performance. A data defect, the code works, but there's a problem with the data that we used, or the data difference between what we used in test versus prod. A data defect, that's how we've got system outage. A security defect. A historic defect. An historic defect is something which we've uncovered a defect in our system, but you know what? It turned out it was there all the time. We just hadn't picked it up. It's an historic defect. And then sometimes there's known defects. And what's a known defect? A known defect is an issue that you knew was an issue, but you went into production anyway because you just didn't have the time, and for whatever reason, you had to prioritize that, and you thought this was not as important as it needed to be, and so you put it there. And so you'll always have at any point in time a list of known defects. So it's good to then understand the defect types within your organization. Why this is important? Because if you now were to start measuring that, if you're having a high number of known defects within your organization that you're now tracking, and you're saying, but hang on, we've had to look at all the defects in our that are in production, and we've listed most of them as now known defects. In other words, we went live with them, and we knew there were defects in the first place, and now that they've been raised, we've logged them as known defects. That shows that we're maybe doing something wrong with regards to actually allowing our releases to go out. We're not doing enough from a quality gate perspective that we've got to pick up. If we're picking up a lot of regression defects, it's picking up that there's something wrong with our unit test process or an earlier testing process somewhere that our regression tests keep on raising issues. Our regression tests aren't supposed to raise issues. It's there to pick up that we haven't done something wrong, but if we're constantly finding issues through regression, we're missing something else, and it's often a unit test problem. But the point is, this gives us information. If we have this type of information within our defects, we can start to build trends, and we can track it over time. The beauty of most defect tracking tools is you can not just stick with your team, but you can often go across an entire organization and do this across an entire organization's thing, and you can start to see big trends as a company of what is going wrong with regards to software defects. The module affected. So again, unpacking, we had a code issue. Which part of the application caused that issue? What's the importance and complexity of that module? Often you find that a lot of defects are sitting in one part of an application somewhere for whatever reason. Is that a problem with that specific team that's working on the module? Is there an architectural problem that's leading to that module causing so many issues? It's worthwhile understanding. Maybe it's just a really complicated module, and that complexity is causing problems. How do we unpack that complexity? Maybe we've built too much complexity. Maybe we need to simplify its design. These are the questions we need to ask. But by understanding the modules affected, and their importance, we can then fix it. And that importance part is also important because sometimes you do have problematic parts of your code, but it's not really getting used too much. It doesn't really affect a large part of our organization. And sometimes it's okay to let's not worry about this right now because it's not important. Yes, there's a lot of defects in that module, but as we've gone through it, we've identified that module is not a critical piece. So at least we know let's not tackle that. Let's tackle where let's maybe tackle where there's lesser issues, but it's affecting major parts of our code. That will become your priority. So it's important to understand that. And then there's things like the root cause. And so this is again understanding now what is going on with the defect. So when we're fixing it, and now we've worked with our development team and we try to identify what did we do to fix this issue? What was it? Was it a code error? Did we find the error in our code and we need to fix the code? Was it a design error in that there were issues in our design and that's what led to the developer or the application failing? So basically what that means is that the developer did the right thing. They coded it correctly, they tested it correctly, but the issue was actually an inherent design problem where it lay somewhere else. Either this isn't a requirements issue. This is often just in the way that these modules are pieced together and now working together. They at an integration point or something. But the point is, at a design point, this failed. It wasn't the developer's responsibility. We know that this is where the design issue was made and related to that. There's the data errors. There's deployment errors where this issue was a result of a problem in our deployment process. Let's log it as such so that we can deal with the environment errors where it was an issue with the test environment, not so much an issue with the code. Why was the test environment or the production environment different? Helps us to unpack these things, performance errors. And so this is a list of things that's very high level and things that we can start to deal with. But then what that does is once you have that high level sort of root cause, and now you're doing this like trend analysis across your organization, now you can start asking the deeper questions. So you've done this trend analysis and maybe you've said, okay, there's requirements issues, coding issues, environment issues, testing issues. Now you start digging into why was that testing issue? So we missed it in testing. It was clearly something that the testing team just missed. They didn't think of the right scenarios, and it's done. But the developer did everything that we thought they did, and this was a feature that couldn't be unit tested right, and so it's rested on the that we've now assigned this as a testing thing. But why? Was the test environment incorrect? Was the requirement tested in the wrong way? Was the defect raised due to an interaction with another requirement? These are the questions we've got to start asking as testing teams to get better. From a requirements issue perspective, did we really understand it? Was it inadequate? What use case was not captured? Why did we miss this? Why did we not think about this? How do we get better at putting it in? Was there a communication gap? Again, these are deeper things that we can start doing. So even if we don't have the time to get into fixing the deep root cause of every single issue, just by understanding trend analysis, we can already start to ask deeper questions within our organization and within the way our teams are operating to be able to get there. And again, these are really important things because this now starts to help us to deal with the root cause of an application. And I think that's a critical thing to do. But then the other thing as well that's come into it is we also now got to start measuring change. So we're finding these root cause issues. We're now trying to use all of this trend analysis to really figure out what's going on with the software. And now we need to start measuring. But now, is it actually making a difference? Are we actually seeing improvement around it? Sorry. So, um, uh, what I mean by that is now we've got to go through actually look at the defects. So we've picked up these trends. Do we actually see now that we've made this fix, we've identified these root causes, does it actually make it better? We solved our requirements issues. Are we now getting less requirements issues, or are we still getting the same number of requirements issues? Maybe we misidentified the root cause, or maybe we fixed one part of the requirements chain, but there's another part that's still not quite right. We've got to look deeper. We've got to look deeper. But it's important that we constantly measure that change. And so I think it's very important to understand that that's an important part as well of fixing or understanding the root cause of an issue. It's not just about digging deeper or asking those questions. It's also about constantly measuring, and that measuring part is important. So I think high level, to close out here, I think as testers, we've got to move away from bug finding. We've got to move away from just wanting to find defects all the time. It's our job to reduce the number of defects. And to do that, we've got to actually understand what's going on with the applications and really get to a point where we want to prevent defects from happening in the first place. That requires a lot of deep introspection. It requires us to understand our software well. It requires us to understand our business well. We can't just surface level test and expect other people to be able to do this. We've really got to understand that to help be a part of that problem solving experience. But because that's time consuming and difficult, the reality is most companies can't do that. And that's why this trend analysis is the best way to start, is to start with understanding what's going on with all the defects within your team, within your organization. And then you start to tackle those high level fruits, delve deeper into those, and you start to fix them. And then as you start to pick up trends and solve those trends throughout your organization, throughout your team, it gets to a point as you're measuring and you're finding success that you can start to then get to start addressing big issues and having a big knock on the impact or the like number of defects that are now going into production. And this will help you a lot. So that's high level. My sort of play today on how you can become a better tester and why solving the root cause of an issue is so important. Time for some questions.
Awesome. Folks, I'll request everyone to post their questions in the Q&A tab. Okay, I'll pick the questions from the Q&A tab itself. Yeah, the first question, I'll just reflect that question on the stage. Resonate with them practically. The challenges of a license. Yeah, Craig, what you want to add on something on this comment?
Well, I think what Solani is trying to say there is that that's the biggest issue, is often that time constraint, and I think that's one of the reasons why we've got to try and do some form of trend analysis. It's very difficult to take the time and fix every single defect, and sometimes we might need to just start with maybe the high priority defects. Maybe we're not going to track everything. Maybe we just track those critical issues and we just start with those as an organization and unpack what do we do to prevent these critical issues from ever happening again, just for the sake of time, that we just don't have the time to do it, and start trying to delve it somewhere else. But we need to have some sort of RCA process. We've got to look at the root cause. We've got to assess something high level. And even if we just start with the most critical defects, that's at least making headway, so that we can then start focusing elsewhere, so that we get out of this habit of just constantly fixing things all the time and dealing with that time constraint.
Yeah, I think that's it. Ansha has a question. Could you please provide examples how implement RCA has led to a significant improvement or changes within the organizations?
Sure, great question. Yeah, I can use quite a few organizations I've worked with, but I think one that comes to mind, and I think this speaks to probably part of a development culture, but we found a lot of issues within a particular part of code that was going on. We were delving into root cause issues, and we picked up, and we used to, I was part of a team that was trying to analyze a big global organizations defects, and so I was putting together these big spreadsheets. At that time, spreadsheets was about over 10 years ago, from our testing tools, to be able to map out where the different trends were, and we were able to pick up a number of issues within a specific type of module across multiple teams. And we were able to, through that information, see, okay, well, there's a certain type of thing that we're not getting right. Each team is having the same problem, and we were able to actually pinpoint that to a module problem, where we were actually able to realize that they were all sharing a similar part of code that was a third-party library, and we actually found some deeper issues within that. And by addressing that problem, we could solve a whole bunch of issues as a result of it. Another big one has been requirements issues. I've seen a big focus on getting the requirements right. I think it's sometimes because we don't understand it enough. It's very easy to fix surface level defects and realize we didn't do this right. But if we ask ourselves, the real questions of, did I really understand what it is that I was developing? And did we really understand the information right? And then you start talking to the developers and how they coded it that way and how you thought about your testing, and you realize there's a big disconnect. That often points to the fact that you can do your requirements better. And so I found that's been key to then getting teams to understand what they need from a developer perspective and from a tester perspective. So when they get together for their 3 Amigos sessions, it generally produces a much better requirements for the team. And I think that helps a lot, and can definitely reduce a lot of defects then further down the line.
Yeah. Awesome. I think Zulani,
There is a question I see on how to deal with the data issue. I'm working in finance domain and most of time facing it. Data issues can be quite tricky, and it depends on, again, what's the cause of the data issue. I think it's just understanding, when we're having data issues, what does that mean? Does it mean that when we were doing our testing, we misunderstood the data? Does it mean that maybe we're not using production-like enough data within our test space, and that's how we're missing it? Maybe there's some test scenarios within the data that are very obscure that we haven't thought of. It's really trying to understand that level of what's, when we say data issue, what does it mean? I think in the finance space, we pick it up a lot because you're never going to test everything. You just can't. There's just too many permutations when it comes to money and people's finances. So you have to just try and narrow down on what part of it didn't you understand. And here's something which I've picked up, which I think is actually quite useful with data issues within an organization, within a financial organization, and I've picked up many within my current organization, which I'm trying to work on addressing, is we have a lot of these data issues because we're constantly thinking of these big data scenarios, but do we understand how each individual function processes that data separately? And often there's a lot of unit testing that we can do from a data engineering perspective, where whenever data is touched by a piece of code and modified, there should be a unit test to verify that it was modified correctly. And just by adding unit tests into the process around your data pipelines, you can often solve a lot of your data problems. And so that's something to look into as well. Do you understand your data requirements well enough, but maybe there's an engineering issue or a process issue where you're not processing the individual parts of your data right, and you're just doing end-to-end testing the data without actually doing some of the small subsets of data. So that's something to think about, and something I've seen quite common in the finance domain.
awesome. I think Nuja, you have got your answer. We have got few more questions. Is there okay? Diksha is asking if yes. Okay, there was one more question. Is it necessary to conduct RCA for all types of issue, or is it sufficient to focus on RCA only for the issues that reach production? Additionally, should RCA discussions be integrated into sprint demo activities conducted by QAs? And if yes, how to build RCA process as a part of your team?
Good question. I would say, firstly, should you focus on RCA for all types of issues? I think it depends on the culture within your team and the number of issues you're facing. I generally have the policy that I don't actually care too much how many issues you find within a team. I'm sometimes comfortable with teams not even logging their defects, because if you're working with a developer and you're like, oh, I found this, the developer's like, oh, okay, great, let me quickly fix it, and then you guys have done it. Sometimes I'm kind of okay with that, but then if it gets to production, focus on it more. So I would say everything in production must always have an RCA, and I think that's a non-negotiable. When it comes to your testing procedures, sometimes it depends on where you are as a team. Like I said, I'm quite loose sometimes with that, but I also came across a team once where they went live into production, and there were over 50 defects that went live into production. Now, for some people that might not be a lot, but for me that was this was quite big, and it was 50 really critical defects. And I think in total, over a couple of months, they picked up over 100 defects related to that release. That points to something's wrong with your testing process. And I actually went to that team and said, you now have to start doing RCAs at a sprint level because something's not right. If you have one release that has that many issues, you're definitely not doing something right. Go in and check it. And then that's when that became part of them having to do it. And they picked up a lot of quite a lot of solutions within doing that process, and they found it quite helpful. So I think there's definitely value. If you're a team that's finding a lot of issues in production, go into actual sprints and do that, and then make that part of your discussions. Bring it up in your discussions as we find in these issues. This is why it is, and it should be part of your sprint retros. And why did we find so many issues? Let's have a look at what's going on at our RCAs. Let's talk about these RCAs. What can we do better? And I think you've got to do that. And I think as a QA, you need to drive that process. You should be raising those things in the retro and actually showing the team, I have found this data, and data is your friend, and why I think trend analysis is so good. Even if your developers don't want to go in and spend time on unpacking every single defect, even if you just high level can assign them to something, and then you show them the data, even if the data is fundamentally wrong, they'll see the data and say, but hang on, that data is wrong. I'm going to help you show that it's wrong. And then they spend the time going in to fix it and then give you the right data. I found that that's a very useful tool. Is use data to help. Data is your friend to help make your software better.
Yeah. I heard a quote which says, "Data wins the argument in the room."
Exactly. And when it comes to software, it's critical. We as testers, we shouldn't just say, we think we've got to use data to really be able to pinpoint your answer. And I think if we delve into that, and RCA is a good way of being able to get data to be able to shape the teams and trends, because I've heard many managers say we don't have a quality issue in my space, and I've heard many developers say, our code's fine, everything's going well. I'm like, well, the data actually suggests otherwise, and it's amazing when you start showing the data, they can't answer those questions. So use data as best as you can.
Yeah, that's amazing. Perfect. Few more questions in the top in just a second. One question: are you aware of any tools that specifically make RCA easier to identify or classify?
Most defect tracking tools are actually not too bad at this. I mean, Jira, believe it or not, I know not everyone's a fan of Jira, but it's actually can build dashboards quite quickly, and you can filter them if you understand Jira well enough. But otherwise, I have found a lot of success with Grafana. So just because sometimes visualizing it's difficult. Sometimes we've got a lot of defects sitting all over the place that we can't quite track. Pushing all of that into like a central database, whether it be Influx or some sort of DynamoDB, and then using Grafana to shape that, I was also found quite useful. But if not your defect tracking tool, try Grafana to be able to try visualize your defects better.
Got it. Next question is, with the evolution of technology and AI, how do you foresee the practice of RCA evolving in coming years?
Good question. And I will say as a caveat, I don't think anyone can predict where AI is going to take us through completely. But where I believe this is going to go, and I think it's actually going to help us a lot, because one of the benefits I've seen of AI is it actually helps you to find that issue a lot quicker. There's a lot of tools. I mean, even just using a Copilot, for instance, against your code, it can help you find the issue in your code. But then it can sometimes you can often tell it to look for similar things, and then it can actually go and find an issue somewhere else, and it can sometimes pick things. I definitely think it will help us a lot. I think from a requirements perspective, we can train AI models to think about certain things from a requirements perspective and help us to always put all these things in check. I don't think it's going to take away our job as testers, but I definitely think it's going to help us. And I think where we're going to get to with a AI perspective, which I think would be quite interesting, is we won't just be able to do trend analysis in the past, but we can start using AI to do trend analysis in the future. Right now, our issues are normally here. You can use AI to be able to, by looking at all the things that we're working on, to start picking up and identifying, we predict that you're going to have issues in this space in the future. This is something to focus on a little bit better. And so I would say that's a key thing that might help us, is that future-looking perspective. Now that we have the data, what can it tell us about the data and where we're headed? And then let's fix those issues before it happens.
Yeah. Awesome.
Good question.
Next question is, The project I'm working on, the development is being done by another vendor of the client, so we don't have any visibility on their process or the source code. In this scenario, how do I start implementing RCA process?
Good question. I think this is a very common thing in a lot of organizations. We don't need to have access in the code to be able to start implementing RCA. It does mean that we obviously sometimes can't play that role, but we need to put it there anyway. So even if you've got a vendor who's producing the code, you have every right to ask them what went wrong, what happened, and to be able to sign. So we had this issue in the code. What did you do to fix it? Why did it happen? Why did we get this wrong? Sometimes, and I have often found this the case, when you start doing that with your vendor, you might pick up that there's an issue somewhere else. And what typically I found is the vendor misunderstood a requirement somewhere, or the vendor misunderstood an aspect of your business or an aspect of your data that maybe they're not understanding. But still have those conversations with them. And I think it's imperative that you bring them in on the call and say, we need to get to this RCA process. Please be on the call. Help us answer these questions. And even if you can't see what's going on in the source code, they should still be able to help you answer these questions. And they've got to be able to identify why did it go wrong. And they should be answering that question. You can't think, oh, that's just this black box you can't touch. If there's an issue and and it involved them fixing it, they can't just say, oh, we fixed it. We need to start asking those questions and expect that of our vendors. Why did it go wrong? How did it go wrong? How did we get better? How do we prevent this from happening again in the future? And I think we should be asking those questions of our vendors and bringing them into this journey. So even if we can't see the code, they're still a part of the RCA process.
Yeah, awesome. I think that sums up his answer. Next question is, how do you recommend dealing with the issues of integration with the third party component being culprit of the issue, especially where the third component is not the is not open source?
Oh, yeah, absolutely. I mean, if it's open source, you would be able to fix it yourself. So definitely understand that. Yeah, I think when it's a third-party component, that does get tricky. And I think what makes it tricky is being able to eventually prove that it is the third-party component, because sometimes there can be a lot of head scratching to be able to figure that out before it's a third-party component. Obviously, if it's a third-party component and you're paying for it, I would say again, if this is a licensed component that you're paying for, there needs to be some sort of understanding that they've got to make a change for you. And I find it very strange when you work for companies, and we have some third-party clients who are like, but this is how the system works, and like not there is something wrong with your system that's causing these issues. And if you can eventually prove that, like I say, proving it's the tough part, but if you can prove it, they need to fix it if you're paying for it. If it's part of something that it works this way because of other clients and it's going to fix something, then you might need to look at how do we as a company work around this. So if it really gets to the point where there's nothing you can do about solving this problem because this is the way their software works, and by fixing your issue, they break another client, then that becomes something where you might need to find a workaround. And what I always advise companies to do is, if you run into that situation, write your own code to do the same thing. Maybe not everything that the third-party client does, but write some code that can at least try and fix that. Really difficult. It does kind of mean that you have to now do extra work and have extra code to maintain. But I really think that does help, especially when you just don't have a clear sort of resolution and owner to be able to fix in these things.
Awesome. Awesome. That is awesome, Craig. I feel what I feel is hearing you giving answers literally give the insight, like why you have chosen the topic root, like finding the root cause of the problem. Like you are
Yes.
literally going deep down and giving all the aspects, like how this particular thing can go wrong, and telling that to the members. I'm really grateful to host you. I mean,
No,
that
thank you
the
so
topic
much. Thanks for
literally,
having me. Always,
yeah.
and thanks for all the questions to everyone on this webinar. Really good
Yeah.
questions, and really like the interaction.
So yeah, Craig, we don't say bye here at Test Right. We say happy testing. So yeah, we'll surely host you again here, and happy testing.
Thank you. Happy testing to everyone.